right, let's go ahead and jump into 4.12. We're coming to the end of the unit here. It says in the past several lessons, we've been working to prove that two triangles are congruent. Now we will be learning how to use those congruent triangles. Number one says, which of the following congruent statements describes what two triangles are congruent? Justify your answer. So the answer was B here. And the reason being is that A matches up with its corresponding, which is P, because if you look at A, it has a single arc, and P also has a single arc. N matches up with V, and M matches up with K. Any arrangement of the A, N, and M. For example, if A came second, that just means P needs to come second. If A came third, then that means P needs to come third. So there's many different variations of how you can write a congruent statement and it be correct. It just, you need to make sure that the corresponding parts match up. Number two says it is given that triangle ABC and triangle DEF are congruent. Angle B is 30. What is angle E? So B matches up with E, as you guys can see here in the congruent statement, which means that if B was 30, E also has to be 30. That is because it is a corresponding part of congruent triangles. So we know corresponding parts of congruent triangles must be congruent. Next, you're given that BC is congruent to DC and that C is the midpoint of AE. Construct a logical argument about how this information can be used to prove that A is congruent to E. So with the given and with the midpoint, you now have two sets of sides that are congruent, and you also have the vertical angles theorem. We would use that to be able to prove that the two triangles are congruent by SAS. Once you know the triangles are congruent, you know their parts must be congruent. So triangle ABC must be congruent to triangle EDC, and therefore we know that angle A and E correspond to one another, and they must be congruent, because corresponding parts of congruent triangles must be congruent. So we have dabbled a little bit with the concept of CP/CTC, but now we're going to be doing it much more in a much more concrete way. CP/CTC just means corresponding parts of congruent triangles are congruent. You can only use this after you show the two triangles are congruent, and that is going to justify that their parts are congruent. Why would you ever want to do this? Well, maybe you just need to show the parts are congruent, or maybe those parts need to be congruent for you to work with two other triangles. So you work with certain ones first and then go from there. So it proves that an angle is congruent to an angle or a side is congruent to a side, and that's why it's listed in our toolbox to be a way to show side congruent to side or angle congruent to angle. Now the beauty of this is if you know how to do proofs, this is just one last step. For example, on this one, if I wanted you to prove the two triangles were congruent, you would have the given, and the reflexive property, and then the triangles are congruent by SSS. You already know how to do all of that. The only last step here is after you know the triangles are congruent, then you would say their parts are congruent, so angle A is congruent to D by CP/CTC. The only other kind of pain with this is that normally they label the order that the points are for the two congruent triangles. Now it's up to you to know, like in this case, that A matches up with D, that C matches up with B, and that B matches up with C. You would need to be able to order the points of the second triangle, or both of the triangles if I don't give you one of them, and state that they are congruent. So once again, this lesson is basically do everything like you normally did, except for you need to know how to state that the two triangles are congruent. And once you know the two triangles are congruent, then their parts are congruent by CP/CTC. Now, this next one, we're going to do the same exact thing. We have an angle congruent to an angle. We have the midpoint, which gets the two sides congruent. We have the vertical angles theorem. We do everything like we normally did. But in this case, we now are going to state that the two triangles are congruent, and I have to be careful with making sure that the corresponding parts match up. A with E, C with C, and B with D. And in this case, it was ASA is the reason that they are congruent. And then their parts would be congruent by CP/CTC. And this last one, how could this be used in a good way? So a kite has two sets of non-parallel sides that are congruent. So on my kite, I went over and labeled it 1 tick, 1 tick, 2 ticks, 2 ticks. It says, how can you prove that the left and right angles of a kite must be congruent? Think how you could have two triangles given a kite. So if you draw a line straight down the middle of a kite, you're going to be able to use the reflexive property on there. So now the kite becomes two triangles. The triangles are congruent by SSS. And if they're congruent by SSS, then that left angle and the right angle, and the left and the right on the top, and the left and the right on the bottom angles are all going to be congruent by CP/CTC. So that's kind of a handy little thing. This is what we're going to be doing in future units. We're not going to be writing out full-on proofs. We're just going to be using the concept of a proof to be able to justify things. Now the next one says summarize what CPCTC means and how to use it in proofs. It means that if two triangles are congruent, then all of their corresponding parts are going to be congruent too. You first need to prove the triangles are congruent, then you can go over and use CPCTC. The next one, you guys looking at this, it says explain why the following proof does not make sense and what is missing. So everything is good except for the fact that they don't have a line where they say the triangles are congruent. And you can't go over and use CPCTC until you know the triangles are congruent, because it is corresponding parts of congruent triangles are congruent. So you need to be able to prove that they are congruent. On this next one right here, it says use CPCTC and the congruent statement to go over and tell me what parts are going to be congruent to these parts. A and B are the first two, so D and E are the first two. They're going to be congruent. Angle C is the last angle, so it's going to be congruent to angle F. And then FD is last and first, will be congruent to last and first, which is AC and CA, whichever way you want to write it. And that's all by CPCTC. Now, this one right here, it says complete the following proof. You guys already have the fact that two sides are congruent. You now have the reflexive property as well, if we're putting these in there. And then if we know that AB and CD are going to be parallel, then we're going to have AIAs or AEAs or CAs. And in this case, it's alternate interior angles. And then with that information, if I look at a single triangle, I could see its two sides and the angle between. So it's going to be SAS. And then lastly, we're going to do CPCTC because now we know the triangles are congruent, so their parts are congruent. So you put all that into your proof. Remember, when I do a fill in the blank proof and parts are filled in, then I'm forcing you to do certain things in a certain order. So on here, this must be the sides are parallel. That's funny. I said it, but then I didn't write it in. I'm going to have to fix my key, but since we're recording right now, that is supposed to say the first one is not AB is congruent to CD. It's supposed to be parallel. And it has to be parallel because that leads you to be able to do the alternate interior angles theorem. The next one would be the stuff about them being congruent. You have the reflexive property. Make sure you put it in the correct order of DCB, and that's by SAS. The triangles are congruent. If the triangles are congruent, then their parts are congruent by CPCTC. On number 5, it says complete the following flow proof. So when we look at this, you have right angles, you have the legs, you have the hypotenuses, so we know we're going to be doing HL. And then after HL, you're able to do CPCTC. Make sure you understand how to use right angles when you are doing CPCTC, right angles when you're doing HL. It would be the angles are right, and then you have to state that the triangles are right. You do not state that the angles are congruent. That would be if you are finishing with anything other than HL. So once again, the main thing of this is CPCTC can be used after you know the triangles are congruent. If the triangles are congruent, then all their parts are congruent. So you can go over and do a proof showing the triangles are congruent, then go over and state that their parts are congruent. And later on in different sections, you'll find that after you do that, you might be able to have those sides or those angles are now parts of other triangles, and you can keep going. The one mistake that I made here, even though I wrote this must be sides are parallel, not congruent, I actually wrote congruent, which is silly. Well, thanks for watching.